Good evening, everybody. This is Mr. Molikash. This is our first video for Math 172 with Johnston Community College. Welcome to the class. Hopefully you've gotten settled in. You are familiar with what's in Blackboard. You've gone through the course walkthrough. You've posted in the discussion board. Maybe you've already submitted your first assignment, which is great. Just want to let you know that, again, this is my contact information. This is my email address if you want to give me an email. And if you have a question that you want to ask, sorry about that. If there's a question you want to ask me that's appropriate for the entire class, then you can ask it in the discussion board under the topic Ask Mr. Molikash. So you might be asking, something to me in an email that might be appropriate for everybody to read, and everybody else might have the same question. So, we can all kind of talk to each other in this discussion board. Everybody can see what everybody's saying. Also, throughout the class, you'll be able to collaborate with other people in the class on different assignments, lab activities in particular. And you'll be able to see the labs. There are 4 of them throughout the semester in Blackboard. So this week we're learning about section 4.1 in the Julie Miller text, and a couple things in particular I wanted to talk to you about are, what's the difference between radians and degrees. So a circle has 360 degrees, and we start at the right side of the circle, and if you put the circle centered at the origin, the rightmost part of the circle would have the 0 degree mark, and then 90 degrees would be up here, and 180 here, and 270 and 360 would be back here again, and so forth. And the more you go around the circle, the more degrees you get. So if you want negative numbers, then you go backwards. So, if you want negative 90 degrees, then you go this way, clockwise around the circle. So what is a radian? Well, a radian is where if you have the radius of a circle, and that radius length is also the same length here as this part of the circle called the arc, then this angle, I'll call it theta, is 1 radian. In this picture, that's called a radian. It's a bigger measure than a degree. There's 360 little degrees out throughout the circle, but radians, there's not that many. You can see that it won't take long before all the radians fill up the circle. So the big question, of course, is with radians, how many of them fill up the circle? So remember, the circumference of the circle is 2 pi times the radius. So you have to copy that radius a little bit more than 6 times, and 2 times 3.14 is 6.28. So a little bit more than 6. 1, 2, 3.14 would be half a circle, and 2 pi would be the whole circle. So it takes 2 pi radians to fill up 360 degrees. All right, so since 2 pi radians is equal to 360 degrees, then we can divide both sides of this by 2. I'm sorry, I just knocked the camera. Then pi radians is 180 degrees. This is a very important fact for you to remember for this class. Pi radians is 180 degrees. And because of that, if you want to convert back and forth between radians and degrees, you can use that fact. For example, radians is to degrees as pi is to 180. So, for example, if you had 45 degrees equals how many radians, then you'd put the 45 here where the radian mark is. I'm sorry, the degree mark. And radians would be theta. We call theta for radians. And if you solve this equation by cross multiplying, then you get the number of radians. Okay? And of course you can reduce the 45 and 180 to 1/4, so that would be pi over 4 radians. Okay, and similarly, if you know the radians, you can go put it up here and then solve for the degrees the same way. Okay, so that's a little bit about radians and degrees and some background on that. There's further instruction on radians and degrees further down in this folder in another video if you want some more instruction on that. This week I've noticed some issues with what these different kinds of velocity. One's called angular velocity, and another one's called linear velocity. And these both have to do with going around a circle, but the angular velocity only depends on an angle. Okay, so there's this omega, and omega is the angular velocity, and you want to see, okay, how many radians can we cover and how fast can we cover them? So in this kind of velocity, do not use length of any kind. So no radius up there. Only need an angle in radians and the time it takes to cover that angle. So if you're covering, pi radians in 3 seconds, then it would be pi divided by 3. It would be the angular velocity. Okay, linear velocity, you do cover distance. You do use length. So you use r here. Okay, so the way that we do that is we have to take this omega, linear velocity, we take this omega and multiply it by the radius of the circle. So what we want to do there is take the length of the arc and figure out how many length units we can cover in that span of time. And remember that, and there's another video at the bottom of this about arc length, but for arc length, and we'll talk more about that in a minute, arc length is the radius times the number of radians. So you can see that this omega up here is going to be multiplied by r. Omega is going to be multiplied by r. So that's what you need to be thinking about between these two things. Okay, angular velocity, do not use length at all. Only use the length when you're doing linear velocity. Okay, and before we go, just kind of remind you about arc length and sector area. Whoops. So in a circle, okay, circle has a radius, and there's a radius here, and there's an angle here. And this angle may be 1 radian, it may be 15 radians. Who knows how many radians it is. So for any length of an arc, we call this S. Okay, and the formula for S is r times theta. I think the book might use L here instead of S, but nevertheless, it's the length of the arc. Okay, now if you want to cover all this like a slice of pizza with cheese on it, or tomato sauce or whatever toppings, pepperoni, the area of this would be 1/2 r squared theta. Okay, and an interesting thing is if theta is 2 pi, remember we're covering the whole circle, right? So watch what happens when we put 2 pi in the place of theta. The 2's cancel out and you get pi r squared. Of course, that's the formula for the whole circle's area, right? Similarly, if we do that with the length of this arc, if you put 2 pi in for theta there, of course, that's the length all the way around the circle, right? That's 2 pi r, which we also know is called the circumference. Okay, so that's if you go all the way around the circle, but 2 pi is for 360 degrees. So if you have less than 2 pi radians, then you just stick that number of radians there and multiply it by r, and you got your arc length. Okay, so again, rewind this video and pause and take some good notes. Get started off on a good foot here in week 1 with Math 172. I'm only an email or discussion board post away. Have a great week.